Hello and welcome to another ASMR coding video. Let's start by making a directory while I explain what I'm trying to do. So we will use a smart meter electricity dataset, and we will also try and use MLflow. However, I don't think we will quite get to the MLflow part because in this video I have to do the whole setup. I haven't used this account in a while, so I think I need to install UV first, which is what I use for package management. Let's just start. Okay, we have Python 3.13. I don't think we have UV. Oh, we do. Oh, maybe it syncs with my other account on this computer. Oh, it's already up to date. I mean, I could have inferred this from the date on the version. Alright, so I think we just do UV in it, and I think we can say we want to use Python. Let me just do Python 3.10 because that's what we currently use at work, and I want to have as little confusion as possible. Alright, so this created us a nice project base with not much in it, but this is where our requirements will go. An empty readme, and this dot signifies the Python version. Alright, and if any of you are curious, even though you should be relaxed and not curious, this is the windsurf editor. This is what you use if you want to do vibe coding, but you want to be cool, so you don't want to use Cursor, which is, I think, the #1 vibe coding tool currently available. And if none of this tells you anything, then don't worry, these are both clones or forks of VS Code, which is a very popular IDE/editor for coding, which I've also previously used. But yeah, this has better AI support and stuff, and I've been trying it out on like personal projects. So using UV, we can just, instead of doing pip install, we do add, and this adds it using pip, I think, in the background to our venv. It automatically creates a venv, which is a virtual environment, and it installs the package. It does the dependency management, of course, and it also installed all of these packages which are needed for Kaggle Hub. But just for demonstration purposes, if you would do pip freeze, which is what like the naive way of making package management is, it tells you everything that's installed. However, we don't necessarily need the specific version of IDNA. This was only installed as a requirement for Kaggle Hub, so putting all of this in a requirement would be wrong. Technically, we only want the Kaggle Hub, and UV manages this exactly for you. So if we look at the Py project, it only put in Kaggle Hub. So this is a way cleaner version of managing your dependencies, and it makes it way easier for everyone else to also install your specific environment later on. It does, however, also create a detailed log file, which has like all the versions, and this file you should never manually change, and leave that to the project anyways. Okay, so we have Kaggle Hub. I'm using this smart meters in London. This is an energy consumption dataset collected by the government, and they made this publicly available. This is, I think, called the Acorn. Sometimes it's referred to as the Acorn Smart Meter dataset. It's very confusing. Anyway, this is available on Kaggle more easily than on their website, and we will use this to hopefully just download it via the API basically. So let's do this, and then I think log in via Kaggle Hub. Does it know the API? We will see. Yep, I think that's the command. And I think we can now just do UV run explore. Oh, I thought it opens a browser tab. Let me quickly figure this out. Alright, so this is now downloading. It's actually a lot of data. We will definitely not be able to work with all of that today. This is mainly for the setup and everything, and then hopefully tomorrow maybe I will have some more time to work with MLflow on this. But maybe AI will surprise me and will make me able to explore this. Alright, so this put the, okay, I mean, alright, to use the interactive cells, we need IPy kernel. I think we also need IPy widgets, but we'll see. Now it's connecting to our virtual environment, and it complains about IPy widgets. Alright. Let's try. Okay, that worked. Oh, so it can do that, I suppose. Right. Dataset, load, path, an adapter, a handle. Okay. Loads a Kaggle dataset into a Python object. Handle and path, okay. Well, I don't really see how this is more convenient. But okay. I don't know. Two required documents. Adapter. Kaggle dataset adapter is. I don't know how old this library is and if the AI knows anything about it. I am importing, I am logging in, I'm downloading, and then I load. However, the load is wrong. Does it tell me, oh, you don't use the load function? But this doesn't help me at all. Alright. I would like to announce that I gave up and I downloaded the data as a zip file. I don't have enough to deal with a new whole library today, so let's return to vibe coding, shall we? Copy relative path, use pandas to open Okay, so the agent is actually really interesting. It looks through the file system of all the allowed folders and found that the file that I told it actually exists. And then it wants to look at the structure. It knows that it's a CSV file. And then it wrote code to look at the first few rows and stuff and get the info. And then it knows, oh, okay, we can execute a terminal, see the output, and now it knows stuff about what the file looks like. And then it already tells us a bit of stuff about the file. And now it wants to plot a tiny bit, but first let's look at what it output. So the file has an identifier for the household. And we have 50 unique households. That's this stat here. If you do the data frame info, we have 1.2 million entries in total, and then 50 unique households. The timestamp will be 39,000. It sadly doesn't tell us if that's times 50, if that works out to 1.2 million. But it could, right? I don't know. My math is really bad, guys. And then we also have energy consumption in kilowatt hours per half hour, because this is an half-hourly dataset, as you might have inferred from the name of the file or the folder. If you just open it with pandas, it reads every column as a string, which, as AI tells us, isn't optimal for analysis. There are so many unique timestamps. The most common, well, that's, I guess. It converted the data types. I did that here. The timestamp, or whatever this column name is, to datetime, and the energy consumption to a numeric column, and it kept the ID as a string. It also figured out that I also like this. Normally AI tells you to use pip install, but I think it noticed that I've been running UV-add, so now it tells me to use UV-add. Or this is now just state of the art, who knows? Sure. Let's run Matplotlib, and now we can execute the plotting code that it did for us. That's cute. I think, does it save it? Oh, it saves it to Okay, now it tells me the stuff again that it found. The dataset contains half-hourly energy readings for 50 households, with timestamps ranging from December 2011 to February 2014. After converting the data types, the timestamps are now properly formatted. Let's hope so. The energy readings are converted to numeric values with 50 missing values. Interesting. And it created 3 visualizations. Let's see where it put those. Just in the main data folder. No, in the main project folder. Not ideal, but okay. Hourly consumption shows the average consumption by hour of the day. Interesting. Daily consumption shows the average consumption by day of the week. And household consumption shows for one single household, which has the ID to the daily energy consumption pattern. Like on average. I don't know. For the whole time? Maybe actually. Oh, for each day, probably the sum or something. Let me see. Household consumption, set index, daily, sum, yeah, the sum for each day, and then resampled to daily. Load CSV data, convert data types appropriately, group and aggregate data. I don't think I ever gave it such a vague task, but that's because I mainly work with databases and not with CSV files where it can do all of this. That's like a lot. I think I only paid 1 credit for all of this too, because I only gave 1 instruction. Alright, let's clean this up a bit. Because this is a lot of different cells and I don't know, AI has this weird habit of putting a comment over everything, like display the updated info. Yes, it's literally a print info command. I don't think this needs a comment, but I don't know when those models stop doing this. Alright, it created a function for us that reads in the data and does the conversions. It still, for some reason, has all these comments. Not sure I need all of these visualizations. I think I will survive like this. Okay. Alright, so ultimately, of course, we want to do some machine learning, so let's ask it to set up like a bit of stuff, and I think hopefully it will install some libraries for us that we need for working with time series. I purposely didn't tell it what to use because I'm curious what it will suggest if it has like free reign of everything. We need to like look at seasonality and all of this, especially if we want to use that Emacs. That is a lot of import. So it definitely wants us to use stats models. That makes sense for the whole time series stuff. Scikit-learn, it's using just for metrics, and then MLflow, because it's nice to keep track of stuff, and probably, I would guess, it's installing MLflow mainly because my the title of my folder signifies that I will probably want to use it. If it made this connection, that's really funny. Okay. Yes, you are allowed to install those. I think this is probably obvious if you use AI or coding, but if you're new to all of this, I would highly recommend that you look up the packages that it tells you to install. It's not impossible to get some malicious code or something if you just install whatever. I am aware of all of these packages, they're really well known in the community, but you never know. Okay, it installed all of this, and it gave us some code, and then it did decomposition, check stationarity. Sure. Let's run it so it knows what it's doing. Oh, I think the script will take a while. Oh my goodness. Well, that was a jump scare. Well, I don't know quite what this is, but I think it might be the decomposed, like the residual, but it's not centered around 0, so I'm not sure. It looks a bit like it's centered around 1, which is weird. Okay, here's the decomposition, I think. Took out some seasonality. How that's the observed data at the top. I then tried to extract a trend, which, I don't know, doesn't look quite right, honestly. The seasonality is probably like a daily seasonality, so it's so compacted that you can't really tell. And then the residual is 0 centered, sort of, but I'm not sure if this is enough. Okay. It then did autocorrelation. Okay. I think we need some of the input for all of that. That's a lot at once. It also used MLflow, which created an error, which it now needs to fix. Okay, so my takeaway so far of using this for doing time series analysis is it's very in-depth, or at least kind of in-depth, like it does a lot for you, but it takes so long. And I don't know if it's my like anxiety, but I'm not feeling the vibes. And if you have no idea what vibe coding is, don't find out. If you do want to find out, I don't know, watch a YouTube video, go to LinkedIn, possibly don't go to LinkedIn, you know what it's like. Okay, it fixed something, I can't even run it. Honestly, this coding session turned a bit into showcasing how the AI messes itself up. I didn't write basically a single line of code in this, but for some reason it keeps writing code to log parameters with MLflow, and it keeps throwing exceptions, and then it keeps trying to fix it. At this point, I don't think it will get anything done, and we probably should just separate experiments. Yeah, I don't think I like that idea. We probably need to do this ourselves. So it did manage to make a prediction at this point. That's cool. I think it's trying out different predictions. I will bring you back when it's done. Hopefully this time without errors. And then we can take a last look at the code and what we should probably do in the next part. Okay, so it did give us the MLflow UI, and I opened this in the browser, and well, I don't know if I would say this was successful, but it no longer throws an error, so for some people that would be successful. It creates a separate experiment for each model config. I don't think this is how you want to do it in MLflow, but it avoids any conflict, I suppose. Generating unique run IDs for each model run, which I think is completely unnecessary because it only has one model run per experiment. You can see here it has one run for this 202 configuration and one for this one, and I think this is old and didn't work. So it did 2 different training runs and logged them under different experiments, which, yeah, then you don't need unique run IDs either. So this tells us that the AIC, which is a training score, is better with the 202, but the root mean squared error is slightly worse, but, well, very close. We can view the dashboard to explore the logged experiments. We can also experiment with different parameters, extend the analysis to other households, and implement cross-validation to get more robust performance estimates. I don't think I will do all of that, but we can take a look at this. This is just a local host view of the experiments. You see all your experiments on the left, and then you can click on the run and you see when you created it. Please ignore the time. You can use tags, which I definitely want to do in the upcoming videos, and we did log the metrics. However, we did not log the training dataset at all. We have no idea what we logged this beautiful image, but that's it. We didn't log what data we used or what yeah, you see dataset used was completely empty. What features, what we did with the data before training, like making it stationary and stuff, that's not logged at all. So these are all things that I want to tackle in the next video. So what this is doing, let's take a quick look. It's looking at the household data. It's filtering the household and then sets the timestamp, resamples. If you want to resample, the default is that it resamples to hourly data instead of half hourly, and then it fills the missing values with the mean in a rolling window, so the daily mean. Okay. And then we have the data, we visualize it, which on this zoom level isn't telling us a lot. Then it does decomposition with the seasonal decompose from stats models, or it at least tries to. It uses the daily seasonality. However, there are like multiple seasonalities in there, which makes it a bit more complex, but that's a whole time series discussion. Alright, so it basically just did like textbook style analysis. It used the seasonal decompose with only one period, which will not be enough. It plotted this. Then we used like basically the first thing that you find when you Google for stationarity, the augmented digifolder test. It checked against 0.05 and figured out that we need to do something about the time series if it's not stationary. In this case it's just doing differencing, and then it plots different parameters. It does prepare the train tested split via the length, and then I'm unsure if I think it's returning to Pandas series for this, which we could log, but we don't currently. The experiment name thing is still very weird. Then it fits with like mostly standard parameters and stuff, and gets the forecast on the test data and then computes the error, and then lots of plotting code again. I would definitely put all of that into its own file so it doesn't clog up the whole main file. You can see we're already to 400 lines of code. We definitely have something to refactor in the next one. Sadly there wasn't too much typing in this one because we mainly let the AI code, but we will be a bit more hands-on in the next one, I promise, because now I actually have a project to refactor. I hope I can make something out of this in editing. I hope you were able to enjoy this the way it is, and thank you so much for watching if you made it to the end. I'll see you in the next one. Bye.